prove the following identities by this. We're going to have two of them here, and the first one we're going to rewrite everything in terms of sine and cosine, and we're working on the more complicated side, which is the right side. So I'm going to write this as 1 over cosine. Secant is that. Cosecant is 1 over sine. And then for the denominator, and this is times. This means times. If there's nothing there, it's a times. And the denominator is a plus, so we have sine over cosine plus cosine over sine. All right. The numerator is just going to be, let's get rid of the double ones. It's just 1 times 1 is 1. So 1 over cosine times sine. The denominator, we have this complex rational. So my common denominator is cosine times sine. And we're just going to cross those two. So we're going to get sine squared of theta plus cosine squared of theta. And when you divide these two cancel. So you have 1 over sine squared plus cosine squared. And that equals 1. Because sine squared plus cosine squared is 1. So you have 1 over 1, which equals 1. Okay, the next one is this one. And I'm going to use the fact that I'm going to use this a plus or minus b squared equals a squared plus or minus 2ab plus b squared. I'm going to use it on both of these pieces. So the first one we have the minus. So that's going to be, this first piece will be sine squared minus 2 sine cosine theta plus cosine squared. And that's the first piece. And the second piece is the same, but everything's plus because of the plus here. So we have sine squared plus 2 sine cosine plus cosine squared. I'm squeezing it in here. Now, since this is a plus, I can basically get rid of the parentheses here. And put the plus back in here. Anyway, I have 2 of these, so that's 2 sine squared. I have 2 cosine squares. Now these two cancels, negative 2 of those plus 2 sine cosine. Those cancel and 0 out. Now we need to get a 2 here. I'm going to factor out a 2. I get sine squared of theta plus cosine squared of theta. This equals 1. It's a Pythagorean identity, so we get 2 times 1, which equals 2. So we proved that identity. Thank you. Have a nice day. Bye-bye.